Hello again, it's Miss D. Today we will be looking at how we can subtract mixed units of capacity. So yeah, the other day we looked at how we can add mixed units of capacity. Today we're looking at how we can subtract. So let's go ahead and look at slide B. So analyze the solutions for each subtraction problem below. What do you notice? What do you wonder? Go ahead and answer those two questions, and when you're ready, you can go ahead and unpause. So what did you notice? Did you notice that the top statement uses fractions and the bottom one uses units of capacity? So here we have 1/4 or 1 minus 3/4, which gives us 1/4, and 1 quart minus 3 cups, which gives us a cup. Did you also notice that both of them converted the units? So we went from a whole to 4/4, and we went from a quart to 4 cups. And we can do that because 1 whole is equal to 4/4. And we can change the 1 quart into 4 cups because even the SPAR model shows us that 1 quart is equal to 4 cups. And because we have like units, we can then go ahead and subtract. So what did you wonder? Did you wonder maybe how the answer would change if we had more than 1 whole? So if we had 5 wholes, maybe 5 quarts, how would the answer change? All right, now that we've gotten introduced a little bit to subtracting mixed units of capacity, let's go ahead and look at slide C. So here we have a 3 reads problem. So you know how the 3 reads goes. We're going to read the problem 3 times, and each time we're going to answer a different question. Let's go ahead with the first read. The capacity of a pitcher is a large container that can hold liquid. So sometimes you'll see lemonade in a big glass pitcher or a plastic pitcher. Okay, so the capacity of a pitcher is 3 quarts. Right now, it contains 1 quart, 3 cups of liquid. All right, let's go ahead and answer that first question. What is happening in the story? All right, so what's happening in the story? Yeah, there's a pitcher and it has some liquid in it, right? That's basically what we know so far. Let's go ahead and read for the second time, and then we'll answer in a few questions. So the capacity of a pitcher is 3 quarts, okay? Right now it contains 1 quart, 3 cups of liquid. Let's look at the next two questions that you're going to answer. So what are the quantities in the problem? So you can use those starters. I can count, I can measure to help you out, and what relationships exist. Go ahead and answer those two questions. When you're ready, you could go ahead and unpause. So what were the quantities? Right, the quantities were, we can count that there's 1 pitcher, we can count that how much liquid the pitcher can hold, right? It can hold those 3 quarts. We can count how much liquid the pitcher has now, right? Right now it has 1 quart and 3 cups of liquid in it. What relationships exist? So we have here different units. We have quarts, we have cups. Maybe in our mind we're also thinking about gallons. So we know that there are 4 quarts in a gallon, right? We also know there are 4 cups in a quart. All right, let's go ahead to do the final read here. The capacity of a pitcher is 3 quarts. Right now it contains 1 quart, 3 cups of liquid. Let's look at the final question here. So what are some mathematical questions you could ask about this problem? Go ahead and come up with some questions. When you're ready, go ahead and unpause. All right, so what were some of those questions? Did you maybe have some of the similar questions that I had? Maybe the problem will ask us how much more liquid is needed to fill the pitcher. Maybe the question might be how many cups are in the pitcher. All right, let's go ahead and take a look at the next slide. Now that we've gotten used to what this problem is all about and we've addressed some of the numbers that we see here, let's go ahead and draw a picture here that kind of shows the relationship between the quantities. So go ahead and come up with a picture for this problem stem. So again, the capacity of a pitcher is 3 quarts. Right now it contains 1 quart, 3 cups of liquid. What could you draw to help you with the possible question it might be prompting us to answer in a moment? So go ahead and draw a picture if you want to. You can use the little piece of graph paper here. Go ahead and answer this when you're ready. You could go ahead and unpause. So when I saw this question, I was thinking about, it's probably going to be asking me about quarts and cups. So I was thinking of drawing here the 3 quarts. So here we have the 1 quart, right? 2 quarts, and that's right and 3 quarts is the total here, right? So each little box represents a quart. In total, we have 3 quarts. That's what the pitcher can hold. And what we have here highlighted is how much is actually filled in the container right now, in that pitcher. So we have 1 quart, and then we have sorry, let me just highlight a little bit more. The 3 cups. So each one of these is a cup. So here we have 1 quart and 3 cups. So here we have 2 cups, 3 cups. So now we have our little illustration here to kind of help us maybe figure out the answers to those questions we came up with, right? If we go back the slide here, we have the questions, how much more liquid is needed to fill the pitcher? Well, I see that we have this space over here, and then we have this missing space here. So I can figure out that answer pretty easily now just by using my drawing. And if we would maybe to answer the second question, how many cups are in the pitcher? Well, we know that 1 quart, when we looked at that relationship, in 1 quart there are 4 cups. So that would mean that I have 4 cups here, 3 cups here. That might help us get our answer for that as well. Are you guys ready for the question? Let's go ahead to the next slide and see what the question is. All right, we'll read it one final time with now the question included. The capacity of a pitcher is 3 quarts. Right now it contains 1 quart, 3 cups of liquid. How much more liquid can the pitcher hold? So this was very similar to the question that we came up with. So we need to find how much more liquid that pitcher can hold. We know it can hold 3 quarts. We know right now it just has that 1 quart and 3 cups. How much more can we fill it up? Go ahead and answer this question any way you choose. We'll go over a few different ways to solve this problem in a moment. Go ahead and solve. When you're ready, unpause. All right, let's take look at one way to solve it. So here we have our little bar model here. We know the total is going to be 3 quarts, right? We know that the pitcher can be 3 quarts. Right now, it's only filled up a little bit, right? It's filled up 1 quart and 3 cups. So we still need to figure out what this green portion is. So let's see how we can tackle this. So if we decompose the 3 quarts into 2 cups and 4 cups, 2 quarts and 4 cups, we've broken it apart into smaller terms where we can, in the same way we looked at the slide B where we had to change them to the same units, right? I can take now 4 cups and subtract 3 cups from it to get 1 cup. And then I can take away from the 2 quarts 1 quart and get that 1 quart. So you see there, what we're doing is we're looking at these 2 parts here. So we use number bonds to rename the 3 quarts into 2 quarts and 4 cups. Okay, so 2 quarts, 4 cups. And we can subtract the 1 quart and 3 cups. 4 cups minus 3 cups is 1 cup. 2 quarts minus 1 quart gives us 1 quart. All right, so again, we can subtract like terms. We did have to rename the 3 quarts differently to 2 quarts and 4 cups so that we can subtract the 1 quart and 3 cups. This strategy won't always work, but in this case, it worked for us here. Let's go ahead and take a look at the next slide. So this is an example from student B, And before we go over what student B did, I want you to go ahead and answer these questions here on the right. When you're ready, go ahead and unpause. All right, so what did you notice? Did you notice that they added 1 cup to get to the next quart? So they're counting on, right? You see 1 quart, 3 cups plus 1 cup gives me 2 quarts. And then from 2 quarts, what do I need to do? Get to 3 quarts. I still have to add a quart. What do you wonder? Did you wonder if counting up can be used for similar problems? Yeah, sometimes I know that most of the time when we make mistakes, it's more so when we subtract than when we add. So sometimes adding or counting up can be a great strategy to use when subtracting mixed units. So what did this make you think about problems involving subtraction of mixed units of capacity? Did this make you think that you can subtract like terms, but you can also count up to get the answer too? So we saw the previous example, we were subtracting. We're here, we're trying to get to 3. We're trying to go from 1 quart, we're trying to go from 1 quart and 3 cups to those 3 quarts. So I know if I add 1 more cup, it's going to take me to 2 quarts, and then if I add 1 quart, it's going to take me to 3 quarts. So I would need 1 quart and 1 cup more to fill up that pitcher. Alright guys, that brings us to the end of this video segment. I hope you found this video helpful on how to subtract mixed units of capacity. Great job. I'll see you next time.